Good morning.
Good morning.
Good morning.
So how's everyone feeling today?
How are you, Mr. Strong?
I'm okay. Anything exciting going on?
No school on Monday.
Yeah, that's a big deal. So not and plus not for NPC either. So that means we all get a holiday, right? Okay, let's see. Is everyone there? Yeah, everyone there in Holbrook?
Ina and Raylan are gone. Oh,
Raylan and Anna?
yes.
Okay. All right. Okay, so today we're going to finish up chapter 3. We're going to do 3:7, and then we are going to probably get into chapter 4. Now, I just sent the student success organizers for the first 3 sections of chapter 4. For some reason, the email at NPC is not, it was actually not working the last half hour or so. And now it wouldn't let me send all the attachments. It only let me send 3. So go figure. I've been dealing with weird issues with the software all morning. So I don't know what's going on. So, okay, well let's go to where we left off. All right. So, so with practice 2B, so let's go ahead and if you get out your student success organizer for 3:7, and so we're on the back side. Okay. So does y equals absolute value of x have an inverse? All right. So if you think it does, thumbs up. If you think it doesn't, thumbs down. Okay? So the answer is no, and why not?
Because it is 2 inverses. Like, that's what it is.
It is 2 inverses. I don't even know what that means.
Well, I mean, like, it has the opposite of each already there.
Okay, so but opposite isn't necessarily the same as the inverse. But I like how you're thinking because the opposite is the additive inverse. So I guess in that sense, but in the sense of functions, the answer that I would be looking for is that the absolute value function fails the horizontal line test because the horizontal line would hit it more than once. So that's the easiest way to explain it. Okay, so it is a function, but it fails the horizontal line test. So the inverse does not exist. The inverse function does not exist. Okay. All right. So next we want to talk about how to actually find the inverse of a function. So to find the inverse of a function, and we're assuming that it's a one-to-one function. So that means it has an inverse. Okay. So if it has an inverse function, then this is the process. Okay, so step one, you replace the f of x with y. Step two, you interchange the x and the y. Step three, you solve the new equation for y. And then step four, you replace the y with f inverse.
Mr. Strong, would you just replace it with f inverse, or would you replace it with fx inverse?
Well, it'll be f inverse of x.
Okay.
So yeah, I guess maybe I'll put that. That's a good point. Okay. All right. So let's go through an example. All right. So let's say that we want to find the inverse function of f of x equals 5 minus 3x all divided by 2. Okay. All right. So step one, we're replacing the f of x with y. So y equals 5 minus 3x divided by 2. All right. Next, we interchange the x and the y. So then it becomes x equals 5 minus 3y divided by 2. So now to solve for this new y, what I would do is multiply each side by 2 and then divide everything by 3. And so then you end up with negative 2/3 x plus 5/3 equals y, and then you replace that with f inverse x. Okay, so then the last step is you just say, okay, so then f inverse x is negative 2/3 x plus 5/3. Okay. All right. So go ahead and try practice 3A. All right, so Rebecca, when you've got it.
Sean, I put freaking.
f of x equals negative 1/4 minus 9/4.
So f inverse x equals negative 1/4 x minus 9/4. I think that's what you said. So, all right. Any questions on that? Anyone like me to work through it?
Yes.
Okay. So first we replace the f of x with y. Then interchange the x and the y. So you end up with x equals negative 4y minus 9. So then to solve for that new y, we're going to add 9. So we add 9 and we get this. And now divide everything by negative 4. And so then when you simplify, then you get negative 1/4 x minus 9/4 equals y. And then replace y with f inverse x. So f inverse x equals negative 1/4 x. Or if you have negative x over 4, that's the same thing, minus 9/4. All right? Any questions on that? All right, so next I want to show you how to check your work. Okay, how to make sure that you're right. Okay, there's actually a lot of ways that you can do it, but the way that the way that I talked about yesterday is the way that I'm gonna do it, is that to verify a function's inverse, see if the functions are symmetric through y equals x. Okay, so let's say I have my original function, all right, and I go through and I'm gonna find the inverse. So here I replace f of x with y, interchange the x and the y, and then solve for the new y. Okay, so here when I solve for the new y, I end up with a plus or minus. So that's kind of weird. All right, and so then you might think, well, that seems too weird to be the answer. Okay, so then what you do is you're gonna put them in the calculator. Okay, so you start off. Well, let's see here. Did I? Okay. So to check your work, you're going to see if they're symmetric through y equals x. So you would put y1 equals x. So you're going to graph that on your calculator. Okay, for the y2, you're going to plug in your original function. So that's x squared plus 1. Okay, and then normally for y3, you would plug in what you've got for the inverse. Okay, but this is kind of a weird one because it's plus or minus. So in this case, you would actually have a y3 and a y4. And so you would get the square root of x minus 1 for your y1, and then this for your y3, and then your y4 would be negative square root of x minus 1. Okay, and so then what you would end up with is when you graphed it. Okay, so the y equals x, that's this line right here. The y2, y equals x squared plus 1, that would be a parabola that opens up. And then when you graphed each of these separately, what you would end up with is you'd get the top half and the bottom half of a sideways parabola. Okay? So even though this function is not, the blue here is not a function, is that you can still get its inverse. But this green graph here is actually not one-to-one because it fails the horizontal line test. And so even though this is its inverse, the blue is not a function because we had to graph it in parts. But that's how you test to see if you've got the inverse correct. Is you do y. So for practice 3b, okay, so find the inverse and then put for y1 equals x. It's always going to be y1 equals x. And then the original function in for the y2, and then what you get for the inverse, put that in for y3. And just see if it's symmetric. All right, so Andres, when you have the inverse, let us know.
It's strong, so I really don't understand this. Could you go like step by step?
Sure. Okay, so to find the inverse, you replace the f of x with y. Then you interchange the x and the y, and then solve for the new y. So to solve for that y, to get it by itself, you're going to add 1 and then raise it to the 5th power. Okay? So you add 1, raise both sides to the 5th power, and then you get y by itself. So y equals x minus 1 to the 5th. And so that's your inverse. Okay? So now to check it graphically, you're going to put in your calculator y equals x for your y1. Well, it doesn't matter what order you do it in. So y equals x, the original function, y equals x to the 1/5 plus 1, and then the f inverse for the y, for the other one, it's x minus 1 to the 5th. So I did the y equals x last, but you can do it it doesn't matter what order. But those are what you need to put in your calculator to see if that's right. So this is what you would do, like if you're saying you're not sure about the answer and it's a test or a quiz, this is how you check to make sure that your answer is correct. Okay? All right, so Andres, did it work out?
Yeah, I kind of get it now.
Okay. Well, let's just see what the graph looks like. Okay. See, you have y equals x, and then you have so your original function is the blue here. I have it in blue, and then the inverse is the red. Now you might actually, when you graph it, it might look elongated, where it doesn't look like a true mirror image. How can you fix that?
The window.
Yeah, you do zoom square. Remember the window is stretched horizontally like your TV. So to make it look true, so you can see things like when lines are perpendicular, or if circles look like circles. If you need it to look true, then it's zoom square. Okay? And so in this case, where you're trying to check out symmetry, you might try that. Okay? All right. So, any other questions on that one? All right. So, remember the domain of the function is the range of the inverse. Okay? So, just for extra practice, let's go ahead and do practice 3C. All right, so Hannah, what do you have for the inverse?
I got x cubed minus 10.
All right, good. X cubed minus 10. All right, so again, you're going to put in your calculator y equals x, y equals the cube root of 10 plus x, and y equals x cubed minus 10. So put those in and see if you get symmetry.
Mr. Strong, how do we put the cube root of 3 into the calculator?
Okay, the cube root.
Uh-huh.
Okay, there's actually a couple of different ways. All right, so, whoops. Okay, so we're going to put in y equals x for the first one. Okay, so then to do cube root, it's under the math menu. So math and cube root is number 4. So math 4, and then 10 plus x, and then you arrow out of that. And then the last one was what? X cubed minus 10. So x cubed minus 10. And then you press graph. So there's the y equals x. There's your original. And there's your inverse. So again, it's a little bit stretched, so I'm going to do zoom square. So zoom 5. And so it'll look a little more symmetric now. So, but it does work. Okay? Any other questions on that one? All right. So that's it for 3.7, and that's it for chapter 3. So, so what we'll probably do is we'll do quizzes 3, 3.5, 3.6, and 3.7 on Wednesday, and then we'll a week from Wednesday is when we'll do the test for chapter 3. Okay. All right. So let's go ahead and get a little start here on chapter 4. So remember, I won't actually see you on Monday. So our next class will not be until Tuesday. And so we'll only have 2 classes next week, Tuesday and Thursday. Okay. So chapter 4 is there's a couple of large sections in it, but for the most part, there's only 5 sections. So it's not a real long chapter, but the focus is on polynomial functions. And so we're going to be talking about polynomial equations and graphs. And so in this section, really graphing is going to be one of the most important ideas in it. And we'll talk about how to find the zeros of a function and so on. The thing that makes this chapter so much easier than it used to be is your graphing calculators. Because if you ever get lost in chapter 4, I'm going to show you some tricks to use your calculator that will help you through the hardest part of this chapter. Okay, and so that will be kind of nice. All right. Now, the book doesn't really show a lot of the tricks, a lot of the calculator tricks, and so we'll just kind of do them as we go along. All right. So first, the zeros of polynomials and solutions of polynomial equations. The number k, and here k could be a complex number, is a zero of the polynomial function p of x if p of k equals 0. Now, some people get confused with that terminology. The zero of a function doesn't mean you're plugging in zero. It's what number do you plug into the function to get zero. Okay? So it's kind of weird to say 3 is a zero. That sounds weird. So 3 is a zero of a function means if you plug in 3 into the function, you get 0. Okay? So this is also expressed by saying that k is a root of the polynomial or a solution of f of x or p of x equals 0. Okay? So if you set the polynomial equal to 0, then it's a solution. So 0, root, and solution are kind of used interchangeably. Or let's say it this way. If you're asked to find one of those things, you do the same thing. You do the same math to find the root, the 0, or the solution. Okay? So we're going to talk about finding zeros, graphing, and solving inequalities. Now, this part, the solving polynomial inequalities, this is probably the part that you might never have done before. Okay? And so, but it's very important. Like what we're doing right now in calculus, boy, it really helps if they remember how we did these. But anyway, we'll see when we get there. Okay. All right. So okay, let's go on. All right. So here we have a polynomial equation in one variable. So we're not going to have multi-variables here. Okay. It's just going to be in terms of x or t or whatever. All right. Now, remember the degree is the highest exponent, and when you put it in descending order, the number in front is the leading coefficient. Okay, so we've used that terminology before, but I just want to remind you that when I talk about the leading coefficient, we need to make sure the polynomials are in descending order. Okay. So this just says verify the given values of x, solve the corresponding polynomials. All right. So if you have to do that, that just means you just plug it in. Whatever it is, you plug it in for x and see if it works. Okay. So if we want to see if x equals 5 really is a solution. So this is kind of like teaching you how to check before we actually solve it. And so there you just plug in 5 everywhere there's an x. And then you see, does the left side equal the right side? And it does not. So in this case, the answer is no. The answer is not 5. Okay? So if that's the answer we got, we made a mistake. We need to go back and redo it. All right? So go ahead and try practice 1A, please. Okay, so thumbs up or thumbs down? Does it check? All right, looks like we're all getting yes. So if you look, now here, okay, so here what I did is I put everything on the left to see if I had any like terms. if you do that, then you can set it equal to 0 and then plug in and see if you get 0, which you do. But you don't have to do it that way. See, the way I did the examples, I just plugged in the number and saw if the left and the right side were equal. Okay? And so when verifying a 0, there is no need to rewrite the equation in the form of the definition. So you don't have to set it equal to 0. You can if you prefer, but you don't have to. You can just set one side equal to the other and see if it checks. Okay. All right. Guess I've just lost the board here. So let's try this back. All right. So let's see if you remember how to deal with complex numbers. So this is the practice 1B. So see if you can plug in 1 plus 2i. And for x, and see if you can get it to work. All right, so what do you think? Yes or no? Okay, seeing a lot of yeses. All right, so let's just see. So again, you plug in everywhere you see an x, you plug in 1 plus 2i. All right, now when you square this, I bet if you made a mistake, it would be on this step right here. So remember, when you square this binomial, you'll get a trinomial. So you get 1, and then multiply these two together, and then times it by 2. So you get plus 4i, and then 2i times 2i is 4i squared. Okay, here you distribute the 2 through, and so you get 2 plus 4i minus 5. All right, any questions on that step? All right, so now let's simplify. So remember, I squared is equal to -1. On the right, we can combine like terms. 2 minus 5 is -3. All right, so here we have 1 and then -4. And so we get -3 plus 4i is equal to -3 plus 4i. And so it does check. All right, any questions on that? All right, next, graphing factored polynomials. Okay, so it says draw the moves. So let's say see what you remember from the function dance for polynomials. So this is the end behavior. Okay, so both ends up, down, whatever the moves are. See if you can remember those. So just kind of draw those in, and we'll go over it. Okay, so show me even positive. Okay, good. Even negative. And odd positive. Okay, it's the right hand up. The right hand's up. And then odd negative, you switch it. Okay, good. So this is what you should have on your paper. And the even and odd is determined by the exponent. Positive or negative is determined by the leading coefficient. So when I say even positive, I'm looking at the exponent first and the leading coefficient second. All right. So let's say that we want to graph the polynomial, a polynomial. Okay, so the first thing I want you to do when you're graphing a polynomial is think of the end behavior, like what we just did from the function dance. Okay, now here they're factored, which in some ways is good, some ways is bad. Okay, it's good because it helps us find the x-intercepts easier. It's bad because it's not as obvious as far as what the end behavior is, the function dance. So what you do is you just imagine multiplying the x's together. So negative x times 2x times x. That would give you a negative x, well, negative 2x to what power? Okay, x times x would be x to the third. So it's going to be negative 2x to the third. So that's odd negative. So you start your graph with that. So you would draw that on the graph, the end behavior. Okay. The next thing you do is you graph the zeros. So remember, if you set each factor equal to 0 and solve, then see for negative x equals 0, that would give you x equals 0. If 2x plus 1 equals 0, that gets you x equals negative 1/2. And if x minus 2 equals 0, that gives you x equals 2. So then you graph those intercepts. Okay? And so for right now, that's all I want is you graph the intercepts and the end behavior and then try to connect the dots. Okay? So what I mean by that is that then you would come to your, oh, let's see, is this going to let me, right? No? Okay. So then what I want right now, again, we're not asking for a perfect graph. What I want is you graph those intercepts, -1/2, 0, and 2, and then you've got the end behavior. Now, and see, we don't know how low this goes. So it might just go a little bit like this, or it might go way up, okay? We don't know that right now, and we're not worried about that right now. What I want is for you to have those 3 points, and then the end behavior. And so you're just going to draw a line connecting those somehow. Okay? All right. So let's see if you can do practice 2A.
Mr. Strong,
Yes,
would you have to like put it in factors before you get the zeros?
correct. Because this is not in factored form like the last one. So the advantage is we know this is even positive. So the end behavior is easy on this one. So what's the end behavior? What does it look like? Both ends up. So that makes that part easy. But now when we factor that, how do we factor x to the 4th minus 1?
Is it x times x times x times x plus 1?
No,
Oh, because that. Oh, it doesn't factor, does it?
it does factor. Because it's the difference of 2 perfect squares. X to the 4th is a perfect square. It's x squared squared. And 1 is a perfect square. 1 squared. So if it's the difference of 2 squares, then if I give you that hint, what does it factor to? Can anybody tell me?
Isn't it x squared plus 1, x squared minus 1?
Excellent. That is correct. Okay. All right. Now, x squared plus 1 doesn't factor. So you're not going to get any zeros out of that. But x squared minus 1 also factors again. And what does that factor to? Keep going, Jill.
Is it x plus 1, x minus 1?
Yes. Okay. So again, you're not going to get any zeros from x squared plus 1. Those roots would be complex. They'd be have i's in it. So those don't show up on the graph. But so what x-intercepts are you going to get from these two factors?
1 and -1?
Yep. This is a -1. Kind of looks like a 7, but it's -1. Okay. So -1 and 1. Okay, so on your graph, so on your graph, you need to make sure you have those two x-intercepts and then have the end behavior. Okay, that's my expectations right now. Oh, and it also says the y-intercept. the y-intercept is easy because you just plug in 0 for x. And so you get the y-intercept will be what?
-1.
-1. Okay? So I want that point on there too. Okay? Okay? So your graph should include these 3 points, x-intercepts at -1 and +1, a y-intercept at -1, and then both ends up. Okay? Now, to check that in the calculator, you'll get the basic look, but it's actually, I mean, and you could get these points on the calculator, but you might not even be as exact as doing it by hand to get those exact points. All right, any questions on this graph? All right, so now go ahead and try practice 2B on the back side. So again, look for intercepts and the end behavior. Oh, and this is the blank you need to finish the bottom. Use factoring and the 0 product rule to find any x-intercept. So that's when you take each factor and set it equal to 0. That's the 0 product rule. All right, so Jocelyn, when you get the x-intercepts, let me know.
X equals +1 and x equals -3.
Good. And what would be the y-intercept?
-3.
-3. Okay? And then it's even positive, so both ends up. And so these are the points that I would want. So -1, -3, 0, -3. Now here, the y-intercept is not the vertex. The vertex, see the two x-intercepts, they're symmetric around the axis of symmetry. So we don't know exactly where the vertex is, but that's okay. We'll worry about that another day. Okay? All right, so we're going to stop there. We'll pick it up from there.